All right, cool. It's 12:02. Want to kick off, welcome everybody to the December version of the online cybersecurity meetup. It's the last session of the year. I can't believe 2020 is going down the drain, whether good or bad. We're here. We're all healthy and good, so welcome. Really excited today to kick the automotive security topic. Thank you to Kamel and John and to Thomas as usual for making the time. It's really good to have you guys. Also really appreciate everybody who signed up. I think this is the most international in terms of attendees we've had, throughout the year. So I think that's really good. I think the community is going to continue to grow. Just really appreciate the support of everybody who's been regularly attending, and please continue to spread the word. As per usual, we're going to do the discussion, and feel free to ask questions all throughout. There's some really good questions already that were asked through the registration, but please, we encourage you guys to ask questions. And also, as always, we will do like a short survey at the end. So please, before you guys completely log out, the feedback is really well appreciated for us to continue to improve our online discussions. So, if you can, please take like a few seconds to answer that, because it really does mean a lot to us. So without further ado, I will hand the, I guess, the virtual mic to Thomas. So yeah, thanks guys.
Great. Thanks very much, Gino. And hi, everyone. To those of you joining us live, and for those watching the recording, hello as well from Tokyo. So as Gino mentioned, we're very excited about today's meetup, particularly to have John and Kamel joining us. And just to highlight the fact that they're both associated with the Automotive Security Research Group, and Kamel can provide more information about the research group in a minute, and talk about some of the other platforms and communities that they're involved with. So I'd actually like to go straight into the panel now, and have John and Kamel introduce themselves. So maybe John, if you could start off by providing a bit of a background of yourself, your current roles, and the work that you currently do with the Automotive Security Research Group.
Great. Yeah. Thomas, first of all, thank you. And hello from Germany. It's a little early here, so I apologize if my brain isn't working 100%, but we'll take care of that later. Just quickly about myself, I am the product security lead at Porsche Engineering. I've been 7 years at Porsche Engineering, and I've been mainly focusing on like EE architecture development. In the last 4 years or so, as we've moved into this new area of automotive security, I started focusing on this area as there's a direct connection between the EE architecture development and security, of course. So that's what I've been focusing on the last 4 years at Porsche Engineering. And I'm also the founder of Automotive Security Research Group. We started this community. It's a meetup community that started, I think, in 2017. We currently have around 5,800 members or so in 40 different locations worldwide. So please take a look. You can go to www.asrg.io and check us out. We focus on ensuring that the automotive products and services are secure, and that everybody in that industry is having what they need to make and build the products securely. So thank you from my side, Thomas, for having me here. I'm really interested about the conversation today as well.
Fantastic. Thank you, John, and appreciate you joining us at the early hour there in Germany. So Kamel, it'd be great if you could continue and give us also some insights about your own journey in the world of automotive cybersecurity.
course. So first of all, I also want to thank you, Thomas, for helping us set this all up. I'm really excited to be able to do something here for the security community here in Tokyo. So my name is Kamel Ghali. I'm a Automotive Cybersecurity Architect at White Motion. White Motion is a lesser known company. We're a subsidiary of the global automotive tier 1 supplier Marelli. Marelli is actually the combined entity of the old Japanese supplier Kawasaki Kansei and the Italian automotive supplier Magneti Marelli. They actually merged a couple of years ago. And at the time, White Motion was a subsidiary of Kawasaki Kansei. So we're now part of the greater Marelli family. So I've been in the automotive industry, the automotive security industry specifically, for almost 4 years now. I started at a startup that was in the automotive security space when I was younger. I was actually still in school at the time. And I've worked both as a security developer and a security tester and trainer. I actually did some private consulting in the industry for about a year in 2019, but I'm happily seated in my little spot in Japan here now. So I've been in Japan for almost a full year now. And I've been trying to get the automotive security research community in Japan started because I was heavily involved in the Michigan branch, which is where I'm actually from originally. Michigan in the United States is where I first got involved in ASRG. And I've been doing my best to get ASRG Japan off the ground, but unfortunately my arrival in the country coincided with the global pandemic. And so it's been a little bit difficult, but hopefully, as things start to get better in the future, we'll be able to have some more excitement going on. But yeah.
Well, awesome. No, thank you very much for that introduction, Kamel. And like Gino said at the beginning, we're very keen to see how we can combine our efforts moving forward to build out the community here in Tokyo as well. So now I'd like to get stuck into some of the questions around automotive security. So to kick off, one of the questions that came up from registered attendees, but is also something that I've had in my mind, is what are the common vulnerabilities that you see, in the automotive sector? And John, it'd be great if you could take that question first.
Yeah, of course. So I have to be honest, I focus a little bit, not so much on the technical topics actually currently. So my answer might be a little high level, I guess. But actually, one of our most challenging topics right now is actually the implementation. There's nothing kind of new that we're discovering or researching about here in automotive security. We're taking all the existing technical concepts that we have from the IT security industry and introduce this or bring it over into some embedded and some non-embedded systems in the automotive products. So from a technical perspective, there's not like too many new things going on here. Actually, what we see a lot of the issues is that the automotive industry itself, the processes, the organization, the way that we've done things for the last 10, 20 years is changing. We have development cycles that are, I don't know, 5, 6 years to develop a vehicle. And when you take this and compare it to what we're doing in the IT industry, you're talking about 2-week sprints. So you have this big difference between the development of a vehicle, of a product, and in an app or some type of software. And this is one of the biggest issues that we're currently seeing, is not really the technical concepts themselves. It's bringing all of this, these new ways of working, processes, methods, organization as well, into the vehicle environments where we're developing this vehicle. So what we're seeing, or I can speak just in general actually here, is a lot of the processes, how do you bring in all of these requirements into the vehicle? How do you ensure the requirements are actually being tested correctly? That's not new, but the way we do it for security. So how do you really test that this security requirement, this security concept is really implemented in every ECU correctly? And we're talking about 100 or so ECUs. So it could be completely different from one ECU to the next. And then how do you bring it all together on a system level or a functional level? Some people are even doing functional viewpoints, and make sure that this is completely tested and that we haven't introduced more risk into the system than before. So this is one of our biggest focus points currently right now is not really the technical side. It's really on the process, the organizational, the tools, making sure that everything is in place and that we can actually test, confirm, validate, and make sure that the vehicles are not only secure, but they are safe. So this is this high level view. I think Kamel, you can probably give a more better detailed look into the technical side of things, but from my standpoint, some of our biggest concerns, our biggest challenges in the industry is actually more on the process side, the organizational topic, and making sure that the right tools are there for us to implement correctly. But Kamel, maybe you want to say something about the technical side of things.
Sure. So as John, as you mentioned, right, there's a huge kind of, I want to call it a culture gap between the traditional automotive cybersecurity or the traditional automotive industry and the way IT and cybersecurity more specifically work, right? Like you mentioned, there are almost five-year-long development cycles for a vehicle. But when it comes to security, right, a huge part of any organization's security posture is its incident response. So if there is a breach, if something has been proven to be vulnerable or can be hacked, you need to react quickly and apply this kind of very fast moving repairs, right, to anything that's broken and vulnerable and needs to be fixed. And this is a kind of a clash because the automotive industry traditionally is very slow, methodical. They have a lot of checks in place before any kind of change gets rolled out. So that change has introduced some friction into this new world where cybersecurity is a major concern for automobiles, right? And this kind of goes into the technical side as well, because until now, maybe 20, 30 years ago, when electronics were just beginning to be introduced into automobiles, you had this internal network that was kind of confined to the vehicle, right? You had different in-vehicle networks, for example, the CAN bus and LIN, for example. These are just examples of automotive specific technologies. They were all contained within this vehicle, but the vehicle didn't communicate very much with the outside world. But come back to 2020, we've got self-driving cars, we have connected cars, we have your cell phone connected to your vehicle, your car is connected to a back-end server through which the OEM can provide emergency assistance or geolocation services to your employer, right? The vehicle, which was once a very closed-off, internalized, air-gapped network, is now exposed to the outside world. And when this network, when this internal vehicle architecture was isolated, there wasn't a huge need for security because, well, yeah, if I broke into the vehicle and plugged something in, I could talk to the network. But at that point, I've already broken into the vehicle. Now we're talking about a scenario in which, as was shown in 2015, when the most famous automotive security research of all time was published, the GPAC, right? When that was published, it showed that through, pivoting off of different vulnerabilities, you have a situation where a vehicle can be remotely controlled by a hacker 100 kilometers away without ever having touched the vehicle. And here you have this huge kind of wake-up call, like, wow, this is actually something that can happen. And this is a direct result of the reckless advancements in connectivity and autonomy that vehicles have been seeing in the last decade or so. So a lot of that ties in to things like lack of firmware signature checks on updates for over-the-air software updates and the way that a vehicle kind of adjusts its software, right? These are things that have existed for a long time, especially to correct safety-related deficiencies or bugs in a vehicle's code. You have the ability, to plug in a mechanics tool and actually reflash the program on a vehicle. But until now, there was no need to have digital signature checks or certificate checks on these updates to make sure they were, official sanctioned updates from the actual OEM, as opposed to customized firmware that a malicious user could then put on the vehicle to introduce some rogue functionality or worse, right?
Hey, no, thank you very much, John and Kamel, for providing a really deep overview of let's say the state of automotive security and some of the big challenges there. Yeah, it's actually really interesting the point that you mentioned, John, that yeah, it's true when it takes years to develop a vehicle, but like software, it can be developed in a matter of the weeks, if not days, sometimes now. And yeah, it's really interesting to see that that kind of arbitrage between those two moments of developing the software and developing the vehicle. And on your point, Kamel, about how some of the actors are exploiting this, I was wondering if you could actually provide some more examples of some sophisticated attacks. You mentioned one about the Jeep hack, but maybe if you wanted to provide more details about that, or some other recent attacks that you think are relatively sophisticated. So quite a well-versed attacker would need to would be capable of conducting them.
So the Jeep hack is, as I mentioned, it's like the poster child for automotive cybersecurity. So I actually, you could play a drinking game at any automotive cybersecurity conference, like take a drink every time someone mentions the Jeep hack, right? So I'm actually not going to talk about the Jeep hack because it's so overdone, right? Like I have it basically memorized, like from A to Z, just because of how often it gets brought up. But more interestingly and more recently, there's one specific hack I want to bring up, and I won't go too in depth because I want to be respectful of everyone's time. But in March of this year, in 2020, Tencent's Keen Security Lab, right? There's Tencent is a giant company based out in China, and they own this security lab called Keen Labs. They released some research that they had been doing on Toyota vehicles, right? This is relevant because it's a Japanese OEM, and this will come back into play later. They released some research that showed that through a vulnerability in the Bluetooth stack that was running on certain Lexus in-vehicle infotainment systems, right? Inside your modern day vehicle, you have this IVI, as we call it, an in-vehicle infotainment system. On this IVI system, it's running Bluetooth for the purpose of connecting to your mobile phone, right? So these researchers were able to find a bug in the way that this Bluetooth stack was implemented. They haven't released the full technical details of this research. This is for responsible disclosure purposes. They don't want to have all the details out to prevent anyone from repurposing that research for malicious purposes. The full details are likely going to be out in 2021 once the appropriate patches have been rolled out. But they were able to use this Bluetooth vulnerability to establish a foothold on the main board in the IVI, right? The IVI is kind of like a box, and it'll have different PCBs inside it, kind of with different dedicated functionalities to each one. So the one running the Bluetooth module was the main administrative board on that device. And because in a lot of Linux systems by default, Bluetooth is run at a very high privilege level. So that allowed the researchers, once they had gotten remote code execution on this device, they had it at like daemon level privileges, which was very high and allowed them to actually escalate to root very easily. And from there, they were able to abuse that microcontroller's position within the IVI to push software updates to the other components inside that IVI. So you have the situation where, okay, Bluetooth is in its of itself, all it does in a vehicle is it imports your contacts from your phone, sometimes your call log history and your text messages, and you can control your media through it, right? Those are the main three functionalities that Bluetooth has inside a vehicle. So it's not a safety critical technology. It's not used inside the vehicle to do anything safety critical, but it provided a foothold that exacerbated this other vulnerability, right? The other boards inside this IVI system, they had no signature checks for firmware updates. So this is, at a very meta level, you can think, okay, well, it doesn't matter that we don't have signature updates because there's no way into this board, right? So it's fine if we don't have these updates in place because this is not a network connected device, right? This board inside the IVI is not connected to the network. Only the administrative board is. But when that administrative board gets compromised and you have root level, remote code execution, then you have a situation where you can push firmware updates to the other boards. You can overwrite filters on their CAN transceivers, right? Initially, this device was designed so that you couldn't send arbitrary CAN messages. CAN is a in-vehicle network technology. It's specific to automotive. It's not only used in automotive, but it was made for the automotive industry. And CAN is a safety critical protocol. It's usually used directly to interact with the in-vehicle components like your body control module, so on and so forth. So through this Bluetooth vulnerability, the researchers were able to then create a backdoor using Wi-Fi, because Bluetooth and Wi-Fi were on the same chip, by the way, which is another very interesting fact, but I won't go too into that. But from there, they could then craft their own firmware updates and send them to the other parts of this vehicle. And essentially, they had a very strong pivot foothold by which they could compromise the rest of the vehicle through this one Bluetooth vulnerability. If hopefully that was what you were expecting.
Yeah, no, that's it's quite it's quite concerning at the same time. Yeah, and John, would you have any other cases you wanted to discuss as well?
Sure. Actually, I won't talk about specific cases, of course. What I would like to talk about is maybe a little bit different viewpoints. Kamel is talking about very technical related vulnerabilities and ensuring that you've done the technical development correctly. What we have in the automotive industry is a very complex situation, because actually what the OEMs are doing is not actually developing everything from scratch. We rely on suppliers, right? So the Bosch, the Contis, all these different types of suppliers which are bringing hardware and software into the vehicles. And this is really important because as we're developing these types of products or vehicles and getting our supply base and making sure that the functions are all there, making sure that everybody's bringing the quality to the table. Actually, those Bosch, the Conti, the suppliers, they're also having, another supply base as well, and another supply base. We're talking, first, second, third, fourth tier suppliers. And this entire environment we have to secure as well. Because, we get open source drivers maybe from somewhere else. So everybody's using the same open source software for a specific driver, maybe like for Bluetooth. And this is coming from a supplier that's not vetted. It's open source. While open source is good in some aspects, it's also open source. And everybody has the opportunity to, give their opinion or give their inputs or, make changes to the code base. Think about also that hardware, you know, these chip suppliers, chips on the PCBs themselves, hardware, we don't just have software vulnerabilities here, we also have hardware vulnerabilities. And then bringing all of this together on a PCB, putting this into a vehicle, connecting it to 100 other ECUs. My point here is not to say that this is complex. My point here is to say that, hey, listen, we not only need to secure the product, but we also need to secure the supply chain as well. How do you ensure that every piece of software is really that software that it says it is, that it doesn't have any type of additional malicious code inside of it? You know, we're always trying to respect this, the CIA model, looking for confidentiality, integrity, our code base, the integrity of our code base, of our software base, of our hardware. How do you ensure that it's authentic, that it hasn't been changed through the entire supply base, or that the hardware on the PCB is really the hardware that it says it is? How do you control all of this in such an environment where you have so many different suppliers involved? It's really a large challenge for all OEMs, for all suppliers to control this. And this is maybe a different vulnerability, a different attack scenario, so to say. But it's something that's really a challenge for us in the automotive industry, and you know, a different look at how vulnerabilities can come into automotive products.
Yeah, no, that's a really, really fascinating point actually around the supply chain, especially given the hardware element, which, I mean, even if you look at the software supply chain, and we've seen that with the recent SolarWinds fiasco about you know, how using different software providers that which are compromised can lead to some serious ramifications. So yeah, it must be a very, very complicated challenge. Also, what you mentioned about the open sources is interesting, because as I think it's like Bruce Schneier always says, just because it's open source doesn't mean anybody's actually checking for the security vulnerabilities.
Right.
So yeah, that's also very interesting to point out. And in terms of, you know, what can the industry do about this? You know, what are some of the best practices that you would recommend for the OEMs, for those suppliers, whether they're providing the hardware elements or the software elements? And on a similar note, what are the kind of industry standards and certifications around this that are now helping to provide some sort of indication of quality or quality assurance on the security front?
You want to go first, John, or you want me to tackle it?
Well, excuse me, that's a big question. Let me go ahead, and then you can follow up and correct all of my stuff. Yeah. So first of all, let's tackle the topic of best practices. First of all, there is no 100% secure solution, right? Let's get that out of the way. As much effort as we put into it, as much money, as much time, we will never get to the point where we have a product in the field that is 100% secure. Okay. So just understand there will be vulnerabilities, there will be security issues. What we will do, of course, is ensure that these vulnerabilities or these types of attacks that will happen in the future, that they are very minimal and have no influence on the safety whatsoever. So first of all, we need to just understand that security, there's not a single solution here. It's something that's a work in progress. We will have to continue this continuously throughout the entire life of the product. And that means until it's really in a scrapyard doing nothing. So first, that's always my first point, is there is no 100% secure solution. The next thing that I always like to tell everyone is, okay, SOP, so start of production, is not end of life. And this, my point here is always to make sure that, okay, we've done all of this effort to make sure that the products are safe and secure during the development phase. But as soon as we put this vehicle into any OEM, to put any vehicle into give it out to sell to a driver, this is when everything changes. Actually, the risk assessments, the penetration test results, everything, as soon as the day after SOP starts, everything changes. So this is a continuous effort. We have to every day be looking at things. We have to be monitoring the field. We have to be monitoring the products. And this goes on continuously until really that product is no longer in operation. So it's not an easy task. And there's no way for everyone to get it right the first time. Okay, so SOP is not end of life. We do a lot of efforts. I really have to admit, the automotive industry is doing a lot in the development phase. They're really spending a lot of time and effort to come up with, to do risk assessments, to do concepts, to understand how this product can be attacked. So there is a lot going on. This development, of course, as you see, the product life cycle is a little bit longer than your 2-week typical sprint. So we always have to remember that, okay, we started doing this 4 or 5 years ago. We're just now seeing the benefits of these security measures coming into the vehicles. So I just want to point out that we need to have a defense in depth model. As we're doing the development, don't, just because you put one solution in place, it's not going to protect the entire system. All right, we need a multi-layered approach. We need to say, okay, if this doesn't work, then this will mitigate. If not this, then this. And every control that we bring into the vehicle is also a different attack vector. So as we build in more and more complexity, we also create more and more issues. So at some point, we do have to say, okay, we spent so much time and effort putting all of this stuff into the vehicle. However, we've actually increased our attack vectors here. So just keep this in mind. Building in too many measures can create too much complexity and create many more issues. Having too less measures can also not contain the risk correctly and create problems for drivers and for the company itself. Risk assessment for me is always key. Use risk assessment. Risk assessment is the way to convey to your management, to the company, where we need to put priorities. And always the question will be why and what's going on here. Use risk assessment to show specifically what will happen if this is not controlled. So please use risk assessment. It's a great tool. I can talk about risk assessment for much longer than this webinar. Focus on the fundamentals, please. Don't forget what we're trying to do here. CIA, control, not control, confidentiality, integrity, authenticity. Don't forget the main fundamentals, because this will drive the security concepts in the vehicles and in any product. So, all right, Kamel, I think that's probably enough.
Very thorough, very thorough.
Please
Do you have anything to add, Kamel, in terms of the best practices?
I think that you mentioned maybe about standards, Thomas. So currently there are two major standards in place. One of them is an industry standard, and the other one is kind of a regulation from the United Nations that was actually ratified this year in June. So that is the United Nations ECE WP29, Working Party 29. Has a very long, complicated name, but at the end of the day, what I mean when I say WP29, I'm talking about the United Nations Automotive Cybersecurity Regulation, right? And then the counterpart to that is the ISO, the International Standards Organization and Society of Automotive Engineers. So it's designated as ISO/SAE 21434. This is a more technical document by the industry that outlines different best practices and, well, not only best practices, but also guidelines for implementing a rigid cybersecurity environment for an automotive company. The WP29 regulation is mostly aimed at OEMs as opposed to the suppliers beneath them, but the suppliers are affected by extension because if the OEM is in charge of guaranteeing the security of a vehicle when it goes out onto the market, they're also going to be looking at the products that they have delivered to them by their suppliers, right? And following the guidelines laid out in them, the WP29 is more organizational and more focused on the actual company as a whole and not the specific technical details, whereas the industry standard, the SAE ISO 21434, is a more technical document and has more in-depth solutions and proposed measures for ensuring the lifetime security of a vehicle. And just to kind of echo on what John said about the lifetime security, there are vehicles that are made in 2009, 2012, 2015 that are driving on the streets in any country in the world that could be filled with security holes. And if they don't have if there isn't a system in place to quickly repair security, and this actually echoes another thing John mentioned, is the fact that you can never assume you're not going to be the target of an attack. You can never assume that your product is invincible, right? You have to assume that someday a security breach will happen, because as soon as it rolls out onto the streets, hackers are very creative and they will attack your vehicle in ways you didn't even imagine, right? No matter how much testing you do, there will always be somebody more creative, someone with a new perspective through which they can target your vehicle. And you have to have a practiced, well-established procedure for correcting these problems when they do arise. And that's really the most important thing is, you don't gain anything by being arrogant. You cannot say I'm never going to be hacked. We have the best security team in the world. We don't need a incident response team. I wish I would love to sell you a security solution that works 100% of the time. But if I did that, and anyone who tells you, this solution will get you 100% security, they're lying to you. It's just the way the industry works. And this is not, an automotive specific thing. This is common to all security industries. Right?
Mm-hmm. And Kamel, if I can actually elaborate here a little bit. So how do you, with such an environment where you have so many suppliers involved, and actually you are not controlling the software and hardware base of your product, what happens when something happens in the field? Think about what processes have to come into place that you actually make a change. How long is that going to take? All these different agreements that have to come in. How is the change management done? How do we push it out to vehicles fast? The mitigation effort there is really huge, and we have to consider this as well, right? How to make changes to the product once we do identify an issue. So
that's kind of like the evil, most taboo question, because the answer to that is simply that the current state of the automotive industry is entirely inappropriate for a flexible environment where security patches can be applied as necessary, right? There's too much rigidness in place in the traditional automotive industry. There's too many roadblocks. This is actually, I want to kind of pivot to something very relevant. Tesla does a lot of their own software over-the-air updates. They're kind of the leader in the automotive industry as far as over-the-air updates go. And a lot of that is likely to do with the fact that they aren't as reliant on the traditional automotive industry and reliant on tons of different suppliers for each of their components. They do a lot of it in-house, which is a interesting solution. It's kind of the answer is you have to stop relying on so many different sources for your hardware and software, because it introduces this, theoretical latency in addressing any issues that arise, right? So Tesla has been, it's always in the spotlight because they're like, they're the very futuristic cars, and they're super cool, and they have like I said, they're the leader in the software over the air updates for vehicles as of now. And I think there's a lot to be learned from studying that strategy when it comes to vehicle design.
Yeah, definitely. I mean, Tesla is really, for me, Tesla is actually not a vehicle manufacturer. It's more of an IT company, So you make a really good point there that this type of business strategy in the future, I see this happening for the other OEMs as well, that they're going to start bringing in software into their own companies, because the hardware still might be designed by someone else, but the software design and maturity should be within the company, because this is where you house all your your IP. But you mentioned another thing is this industry is changing, because ECUs used to be developed as the cheapest component you could actually do. And we used to discuss about, okay, do I spend 1 cent here or 1 cent there, or do I really need this component? And you used to make these ECUs so function specific that actually they could only do one thing, right? And now as we shift from this very specific functionally based architecture into this, very flexible, wide, updatable, it's completely different than what we used to do in automotive. So we're switching over from, we're going to dimension the hardware in software really to specifically do this and only this, to now we're going to develop hardware and software which is flexible, it's updatable, it manages the entire platform of a vehicle or a product. It's really different, and while it's great, it's flexible, it's updatable, it also introduces new attack vectors, so new challenges. So really, really interesting point, Kamel.
Yeah, thank you both very much for addressing those concerns. It actually also answers a couple of the questions that we already had from the audience around handling, how would OEMs handle the complexity of the hardware and software from so many different providers, and there was also a point around Tesla and the way that they manage things, and also in general. I mean, it just goes to show how important this all is, because a 0 day for a car can cause deaths, depending on how they're exploited. If it's like some remote access, which for the most part isn't usually the case for other types of 0 days. Of course, there are, if you're talking about medical devices and that sort of thing, or nuclear power plants and stuff, but the fact that cars are so ubiquitous is it's just very scary for me, honestly. And I don't drive, so I guess that's my auto security defense layer. So we do still have some time. So if there's some more questions from the audience, if not, I'd actually like to pick up on the point that Kamel mentioned around the UN ECEWP.29 standard, because we had a question from one of the signups around how is this being implemented here in Japan, and the broader question related to that is what is the state of automotive security in Japan in general, given that it is home to so many global OEMs, and then how does this ecosystem in Japan compare with Germany and the US, two countries obviously with big OEMs as well. So maybe I don't know, Kamel, if you want to take this question first, and then
Sure.
John, if you could elaborate.
Of course. So here in Japan, the Japanese government already has a system that is linked to what's called the Motor Vehicle Transportation Act. I believe that's the acronym. I might have switched to the letters, but it's the law that basically dictates the rules for vehicles regarding technology and the introduction of things like ADAS systems. So in the past, this was mainly used to provide guidance for, self-driving systems, et cetera. And because Japan was being they were actually very ahead of the game regarding security, because they were expecting that autonomous vehicles would play a large part in facilitation of the 2020 Olympics, right? It's totally out of the blue, but the Olympics and the fact that autonomous vehicles were expected to be a huge part of this in 2020 kind of behind the scenes pushed the Japanese legislature ahead of any other country in terms of laying out details for how cybersecurity will be handled. So I've seen news articles going back as far as 2017, 2016, where hacking is explicitly named as a potential cause for an accident caused by an ADAS system. And the Japanese government was already beginning to lay the grounds for one of the biggest questions when it comes to automotive security, is liability, right? So even as far back as 2017, they had ruled that in the event an ADAS system causes a car crash or an incident, if there is evidence to show that hacking was the initial cause for that incident, then the owner of the vehicle is relieved of responsibility. They are not liable for that incident, with one exception. If this owner has, for whatever reason, not applied all of the available security updates to their vehicle, then they remain liable in that case, right? So this is as far back as 2017. Japan was really ahead of the game, which is kind of an oxymoron for anyone who's working in the Japanese cybersecurity space, because Japan is also still kind of behind in some other places. But they were really ahead of the game when it came to the automotive, because they had already established this liability framework for vehicle incidents caused by hacking. Of course, you have to have evidence that hacking has been done, and then it goes into whether or not this vehicle was up to date to the best of the owner's ability, right? Here in 2020, because the Olympics were, of course, delayed, we didn't really see that kind of rollout of autonomous and ADAS-equipped vehicles as we were expecting. But the Japanese government has already adapted the UN WP29 regulation into their MTVA, right? And this is important because the UN can't order any country to obey it. It puts out this regulation, and there's a long list of signatory countries. Japan is one of which. Interestingly, the United States and Canada are not signatories of the WP29. Very strange. But Japan has been very, at the head of the game, because they've already incorporated it into their country's law. It's already part of the Japanese law. The newest iteration of the Motor Vehicle Transportation Act states that any software update, as of now, any software update that goes to a vehicle, if this software update is directly linked to an ADAS system, it needs a security evaluation, right? This is one of the things that they've stipulated, right? Because when each country implements WP29, they're going to add their own little twist to it, their own unique perspective based on their own market and their own, culture and environment. So Japan has decided that any update that goes to a vehicle needs to be checked if it's related to an ADAS system. But in the future, any update period will need a security check, right? So they've made this distinction between the kind of transition state that we're in now and the future, where 99+% or 90+% of vehicles are equipped with ADAS systems. They've also instituted this necessity for vehicle data logs, right? So according to Japanese law, for security purposes, you need to keep a record of all vehicle data that is generated for no less than 6 months. This is used for digital forensics in the event there is a vehicle crash. If hacking is considered a possibility for why this happened, that vehicle data needs to be available to be examined by a designated authority, right? So the Japanese government has actually been very upfront and ahead of the game when it comes to automotive cybersecurity legislation. On the surface, at least, the details of these are still kind of vague because they're like, okay, well, who are the certified authorities to do the incident reconstruction and digital forensics in the event something like this happens, right? It's still kind of up in the air, but as of, I believe, November of 2020, the Japanese government has already begun to accept applications for vehicle type security approvals. This is one of the two main topics that the WP29 addresses. The first is the overall organizational cybersecurity management, and the second is individual vehicle type approvals. But that's, sorry, I'm talking too much. I'm going to let John go ahead next.
No, actually, Kamel, you did a really nice job of explaining the WP29, and Japan is really doing a nice job of implementing this and driving the regulation in the country. So I really give Japan a lot of credit here for being one of the first ones to do it and to hold the manufacturers accountable and suppliers, of course. What I'd like to add here, Kamel, is you talked a little bit about Japan, and you touched on, okay, what's going on in the rest of the world, USA, what's going on in Canada, what's going on in China. I mean, China's a huge market for any automaker as well. And actually, because they're not part of the UN ECE WP29 regulations. So actually, China is already developing something as well, kind of based on the same, I think it's GBT something. It's still in the development phase, and drafts are available, but they're basically taking over what's coming in from the UN ECE, but of course they're adding their own flavor, like you said. And what's really important for China is that they actually are getting more technically deep into the implementation. And this means really the validation. How do they verify that the automakers or the suppliers are actually providing what's necessary? And so you see a lot more test specifications and stuff like this, which is good and bad. So this can bring, the deeper you get into the technical parts, okay, then that's good. But then over time, these need to be adapted and maintained and continuously updated to meet the needs and the needs of the market. So China also doing some great stuff there. Happy when this is released and to see what actually happens. And in USA, I also expect that we will see some type of regulation come into effect. I believe the USA and Canada are kind of waiting to see how this all pans out with the UN ECE, with the China regulations coming. So we expect also to see some stuff coming from USA and Canada, in other countries as well, as soon as we see how successful or unsuccessful could be also that the UN ECE WP29. I think this is the R155 and 156, if I remember correctly, but don't hold me to that. So, and one of the other questions that we had here as well, Thomas, was, okay, how is Europe also managing this? So first of all, Japan, and then Europe. And Europe, or Germany, is, from my standpoint, all of the German automakers are doing a very nice job of taking this WP29 and implementing it. Really seriously taking all of these different requirements, using the ISO 21434, which is kind of the add-on from WP29, which is the regulatory mechanism, and then into an ISO standard, which was originally started by the SAE J3061, and translated into an ISO 21434 with the focus on the WP29. So I see also in Europe that the automakers have taken this seriously, and they are really spending the time, effort, and resources to bring secure products on the streets. So I have to give everybody's doing a good job taking these regulations and making the best decisions for us, the drivers, really. So happy to see that.
Great. No, that's very reassuring to hear, especially given all the all the sort of scary scenarios that we discussed earlier, and also very reassuring about the situation here in Japan as well. I'm always wondering about how the OEMs would force people to make sure that they're patching the software. So that they're not held accountable. We only have a couple of minutes left, so before I kind of close it out, I'd really love to get your thoughts on any resources or ways that people can find out a bit more about automotive security and the activities of the Automotive Security Research Group, and how anyone can kind of get started in hacking cars, in other words.
So I think I definitely have to give a shout out to ASRG, the Automotive Security Research Group. We have branches in, I believe, every continent except for Antarctica, and we have over 5,000 members worldwide now, and we've been doing these kind of web-hosted webinars due to the pandemic. But originally, this was kind of a local community-centered community. You would have in-person meetups maybe once a month where you have anyone is allowed to give a presentation on anything security related. It's participation is free, and we highly encourage people to spend the time. Maybe you might learn something new, do networking, find a new customer. There's a lot of motivation to joining the ASRG. We have a branch in Tokyo. It's currently run through the Meetup app, I believe. This is where the events are kind of broadcasted and announced. And you can find it by searching ASRG JPN in the Meetup app. You can follow us and join the group. And we'd be happy to have anyone who's interested present on anything they feel is automotive relevant. We're always happy to have you. Other than ASRG, I have to recommend the Car Hacking Village and the Auto ISAC, I suppose. So the Car Hacking Village is kind of a community based around car hackers. Car hackers is a slightly different designation than automotive security experts because they do things a little bit differently, but they are the ones who provide most of the important research that ends up providing bug fixes, so on and so forth. The Car Hacking Village is an organization that makes appearances at different events worldwide. For example, at the DEF CON, Black Hat, and Hack in the Box event series. These are very large events that are centered around cybersecurity in general. Car Hacking Village will usually be there to bring that automotive security spice to the event. They'll have live demonstrations, different talks by different experts. Myself and John, I believe we've both given demonstrations at Car Hacking Village in the past. And it's really a great place to learn, to network, to find more information. There are tons of people always happy to help you and kind of set you on the right direction. And yeah, the last thing I have to say is get on Twitter. And that's where all of the major disclosures happen. As dumb as an answer as it is, it's actually the best one, is get on Twitter, find the people who are publishing this research and follow them, because they always have something unique to talk about, some kind of new research they're doing, some new vulnerability they've discovered, or even just, you can always just send them a message and ask. And a lot of the times the car hacking people are very cool. They'll usually just respond to you.
Most of the time.
Not most of the time. Everyone's busy.
Hey, John, anything you'd like to add?
No, I just want to, regarding ASRG. So ASRG, we're trying to make sure that everyone in the industry has the competencies, has the networking, to make sure that if you're working in the automotive security industry, that you have what you need to make the best decisions or to give the best recommendations, We're really there as a supporting community. Please check us out, get involved, send us an email, Twitter, Slack, wherever you'd like to discuss. We're basically on all the different communication channels. And I just want to say one last thing here too is we are all drivers, or most of us, right? So Thomas, sorry, besides you here, we're all drivers, and so that means we're all affected by these products, yeah, these vehicles, and it's our responsibility as users of the product to challenge and really research, to look into the vehicles, to make sure that the OEMs, the people who are providing these products, are really providing secure products. So my thing is, please do research, look into things. However, we also need to disclose vulnerabilities correctly. We do not want to jeopardize anybody's safety. So if we do research, if we do find something, reach out to the correct people. This could be through ASRG as well. You can disclose vulnerabilities there as well, but do it responsibly. Don't put it into a magazine. Don't put it into a newspaper. Come to the source and make sure that we don't put anybody else in danger. Okay. So
I want to kind of touch on that because I am the one who brought up Twitter. The people who post their discoveries on Twitter, they will usually do this after they've gotten in contact with the OEMs. There's a whole responsible disclosure is almost twice as important in automotive because this is a car with people in it. So they will usually have, after they talk to the OEMs, then they will disclose on Twitter or even in Wired or other articles or newspapers that appreciate security news, right? So
fantastic. No, thanks both very, very much, especially John dialing in this unreasonable hour in the morning in Germany. And I think it's been a really, really interesting discussion and has motivated me to try and get my driver's license back. Now that I know that my car is more more secure, just to let everyone else know that we have some topics lined up for next year as well. We'll be confirming a few other slots for the months for March ahead, and these are some potential topics that we have in mind. Still confirming speakers and dates, etc. But we're always welcome for suggestions on new topics as well. Finally, just a shout out. So we now have a Twitter account, so feel free to follow that and to tag us for anything as well. We'll be posting any announcements and updates about upcoming meetups on there. We also have a community on LinkedIn. Feel free to post things in that group. It's relatively quiet. Most of the posts still come from us, but it is open. So the idea is you can post and engage with people there. And finally, just to re-emphasize that after you leave the Zoom today, there'll be a short survey. So we do appreciate your time. I know we're a little bit over time now, but any feedback that you have is very, very useful. And lastly, given this is our final meetup of the year, wishing everyone a happy new year, nice end to this year that has been. I'm hoping next year is much, much better. And for those of you celebrating the various different holidays, happy holidays, Chag Sameach, happy Hanukkah, Merry Christmas, etc., etc. So thanks everyone for that.